Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. For tonight, we're going to continue and actually wrap up a series focused on advanced topics in computer science. And tonight, we're going to look at constructing and searching and sorting algorithms. My name is Mike Houston, and I'm a moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm really excited to be joined by our two panelists tonight, Tony Norell and Michelle Reinhardt. Tony has over 25 years of teaching experience from 5th grade to college algebra. She works as a math specialist and a TQ regional instructor, and she is also the recipient of the Presidential Award for Excellence in Math and Science Teaching. Currently, she and Michelle are developing and delivering computer science professional development across Texas. Tony, thanks so much for being with us tonight. And Michelle, born and raised in rural Ontario, Canada, studied mathematics, physics, and education before moving to Texas. Michelle has taught high school math and science at rural districts in Texas while also working as a math and science consultant throughout the state. Her interests include technology integration, conceptual understanding, and curriculum and instruction. Michelle, it's so great to have you with us tonight.
Thanks, Mike. Glad to be here.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send any questions to Michelle or Tony using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues, but in the event that you do, try selecting Communicate in the WebEx menu and choose Audio Broadcast, and then click Join. Tony, would you mind discussing our agenda for tonight?
Sure, Mike. So on the agenda for tonight, we're going to look at these advanced topics in computer science, constructing, searching, and sorting algorithms. And we're going to look at a program that Michelle and I wrote on Guess My Number. And we're going to look at a couple of different strategies, the linear search, and then we're going to look at another strategy using a binary search. And then we're going to look at some pseudocode and talk about a bubble sort and coding a bubble sort. And then we're going to pose an additional sort challenge.
Thanks so much, Tony. And Michelle, would you mind discussing our expected outcomes for tonight?
Sure, thanks, Mike. So by the end of this session, we will have modeled and solved computer science problems together using both linear and binary searches. We'll also compare and contrast those searches along the way. Together, we'll have constructed some searching and some sorting algorithms, all while reviewing some important topics for computer science certification exams or computer science standards.
Thanks so much, Michelle. And give me 1 second. Michelle, you should have control. It's all yours.
Thanks, Mike. All right, welcome everyone. Our work in this webinar centers around this standard from the 241 Computer Science 8 through 12 certification exam here in Texas. Other states have similar CS certification standards or have similar student curriculum standards in computer science. So from competency number 9, the computer science teacher knows how to construct, compare, and analyze various algorithms. Specifically, the beginning teacher constructs searching algorithms, including linear and binary searches. And the beginning teacher constructs sorting algorithms, including but not limited to selection, insertion, merge, and quick sorts. So tonight, we'll start by exploring some different searching algorithms, and then we'll progress into some sorting algorithms, pardon me. So I'm going to switch over to the software for a minute. And we're going to start by first exploring a program called num game, which Tony mentioned earlier. And this is a program that Tony and I wrote last year to kind of be used as a guessing game and to unearth a number of different ideas about searching and also some of the mathematics that underlies these computer science ideas. So here's how it works. I'm going to run the game, and we're going to be asked how many numbers we would like to play with. So let's say 20. And what will happen in just a second is we'll see an instruction that we are supposed to guess a hidden number that is an integer from 1 to 20. We'll also receive some visual and audio feedback about what a guess that is too low will sound like and what a guess that is too high will sound like. And then we'll be prompted for our first guess. So let's go ahead and say that we want to play this game with 20 numbers. So hopefully you heard both of those tones. The first tone, the higher pitch, is telling us that our guess was too high, and the second tone with the lower pitch telling us that our guess was too low. So there are a couple of different ways that we can approach this guessing game, and I'm going to share one strategy first. So one strategy is to guess each number sequentially from 1 through 20. So we could literally search or guess through each of the possibilities in order, knowing that eventually we must guess the correct answer. So for example, I'll guess the number 1, too low, 2, too low, 3, too low, 4, oh man, 5, what about 6, what about 7, what about 8, what about 9? Oh, okay, I won, 9 guesses, the answer was number 9. So let's pause here and share some of our thinking about this particular strategy, about guessing through or searching through each of the numbers, the possible numbers sequentially, to find the right answer. What are your thoughts about this strategy? Is it effective? Is it efficient? If so, when? If not, why not? Just take a minute or two to share your thinking in the chat about this particular strategy.
So I'm seeing some comments, Michelle, that it could be really inefficient if we were dealing with large sets of numbers.
Okay, interesting. I'm seeing someone sharing about how it's similar to strategy students might use for guessing and checking. Like, it is very systematic, right? It's moving through each of the possible numbers. So it sounds like it is effective, like it should eventually land us at the right number, but it sounds like there's some pushback about it's not always perhaps the most practical. What about we've got large number sets, et cetera. Yeah, so those are all great ideas. So as y'all have shared in the chat, and please feel free to continue the conversation in the chat throughout the webinar. This isn't a bad strategy. It actually is an effective strategy, as it will eventually find the correct value, but it isn't always an efficient strategy. In this case, it would have been very efficient if the random number chosen was like a 1 or a 2, right? Then I would have guessed the right number right away, but it might have been very inefficient if the random number chosen was 19 or 20. And then as Sarah and some others mentioned, well, what if there were 500 or 600 or whatever random numbers, how would it have gone then? So this type of searching that we just modeled here, where you check item by item through a list, 1, 2, 3, 4, 5, 6, is an example of what's called a linear search, where we're doing just that. We're checking kind of all the possibilities one at a time in order. So now what we'd like to think about is how could we write a program that would actually automate this linear search for us? In other words, we'd like to write a program that will guess 1, then guess 2, then guess 3, then guess 4, etc., until the correct number is guessed. So that's what we're going to try to do next, actually write a program that would have given the input kind of like I did as a user. So let's start by inserting a new program. So, oops, kind of made a mistake there, sorry y'all. We go to Menu, Add Program Editor, we'll insert a new program, and we'll call this one Lin Search for linear search. And we'll start by setting up the program with 2 lines of code. So first, let's ask the user how many numbers they want the random number selected from. So kind of like that last program where it asked us how many numbers, and then we said 20. So we could start by inserting from the input-output menu a request statement, and we could ask the user how many numbers, something like that maybe, question mark, comma, and then save their response to the variable n. And there's some previous webinars we've done in this series where we've looked at different request statements and how to get input from the user and give output to the user, so you might want to refer back to those as well. So that's one line of code. Let's insert another line of code where the calculator actually determines a random integer function from 1 to n. So n is however many numbers the user told us they wanted to play with in the game. So if we said 20 for what we just did, 1 through 20, it'll randomly select an integer from 1 through 20 inclusive. And then we'll also start this line with something like target gets. And this first part is just going to create a variable called target and then store in whatever random integer was determined from 1 through 20 or whatnot into that variable called target. So target is going to be kind of the number that we're trying to find, that we're trying to guess towards. So our task now, as we've kind of set up the beginnings of this program, our task will be to guess what value is stored in target, and we'll use the linear search method we modeled earlier, guessing 1, then guessing 2, then 3, etc., until we guess the value that's stored into this variable with a random integer. So here's our question to y'all. How might we write a program that would guess like this? Like what components do you think might be in that program? So take a minute or two to share some of your initial thinking in the chat. And as always, this is absolutely rough draft thinking, so feel free to share any of your preliminary ideas, even if you're like, I don't know the entire code, but I feel like it should probably have something like this in it or whatnot. So the question again is, how would we write a program that would guess through the numbers like a linear search? What components might be in this program? Take a minute or two to share your thinking.
So Michelle, I have someone saying that it's definitely going to be sequential, and so maybe we need some sort of a for or a while or something to go through those numbers.
Okay, so some kind of loop structure to do something again and again. Okay, that's interesting. What else? Who else has ideas to kind of add or to further the conversation about what else might need to be in this program, or any other thoughts about the loop part? I'm also seeing someone saying maybe we need an if-else in there. Does anyone want to elaborate on that? Like what might we need an if-else for? So take another maybe half minute or so to kind of share some additional ideas in the chat about what we might need and why.
So I'm seeing some comments about maybe the if-else would have something to do with the sound, you know, telling you whether you're too low or too high, and
nice.
Maybe some sort of a print or display statement in there.
Nice. And then I see another comment that just came in about maybe that if-else is looking for like incorrect data and would stop if it is correct. So maybe it would stop if we guess the right number or whatnot. So lots of interesting ideas coming out of the chat. Thank you all so much for sharing your thinking there. And now we're going to try to put some of those ideas together and try to code this program out all together. So I heard someone sharing about this idea that we'll be checking to see if the target is 1 and then 2 and then 3, like checking again and again and again. And so that repetition indicates that a loop structure might be helpful here. And I know someone mentioned like there's a couple options we might do for that. So maybe from the control menu, for our purposes, we might start with a for loop. Not our only choice, but we could do a for loop in this instance. And then also notice that someone said that we wanted to check to see if the target had a specific value. That tells us we will want to have an if conditional somewhere inside our loop that we are checking again and again. So we'll start by building in this for loop. We've inserted a for loop, and it's going to repeat a set of commands again and again. The syntax for a for loop requires a loop variable, and we'll use the variable I here, as well as a start and an end value for the loop. So does anyone have any thoughts on what should go kind of in these blanks? Like what should our start value be for our loop, and what should our end value be for our loop? Any thoughts on that? And more importantly, I'm sorry, I should have asked why. Like, why do you think it should be whatever the options might be?
So I see a comment about starting at 1 and ending at N.
Okay, so that sounds good. I see a couple of people saying that. And then if we tried to put into words like why does it make sense maybe to start with I has a value of 1 and end when I has a value of N, right? And so you can kind of share some of your thinking in chat there. We can think about how this relates back to my strategy for guessing, right? My first guess was the number 1, and then 2, and then 3, and then 4, and I was going to keep going if I didn't get it right until I hit that uppermost number, possible number, which in this case was N because of how we set up our rand_int command. So that looks great. Thanks, Shaul. So we have this for loop set up. Sarah, as we want it to work through a whole set of values for the variable, I think that's a great way of thinking about it as well. So with this syntax, yes, ma'am.
So if we set up this for loop, can we put inside of there what our guess is each time?
Okay, so like maybe display to the user, is that what you mean?
Yeah.
Okay. So we could maybe display something like guess is, and we've written that as a string. We talked about strings in a previous webinar, comma I, and so maybe it'll show us like your guess is, and then I would initially have a value of 1, right? And then guess is 2, guess is 3. Is that what you meant, Tony? Like to kind of show them on the screen as it was guessing?
Yeah, yeah, I like that. Thank you.
Okay, so let's try that. So if we quickly run our program here, I'm going to go menu, check syntax and store, and run. And notice there's this shortcut here of Control-R to run a program. I'm going to be doing that in the future, but I'll run it from the menu for now. So I'm going to run this program, and let's see what happens when I run linsearch. It'll ask me how many numbers, and we said we wanted to do maybe 20. Okay, so it guessed the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, all the way down through 20.
So how do we know if one of those guesses was correct?
Gotcha, because we just wrote a loop that basically displayed all of the guesses, but didn't actually check to see if any of the guesses were correct, right? If any of them are actually equal to the target value. Yeah, good catch. So let's do that. And that relates back to something someone mentioned earlier in the chat about we actually have to check to see if that's true. We need to check to see if our current guess is equal to target. If it is, then we'll include a celebratory statement, maybe something like, woohoo! But if not, then we would maybe have a statement such as, sorry, guess again, to let us know we weren't correct yet. So it kind of sounds like we have two cases, right? Either we've guessed the right number or we haven't, which is a nice fit for an if-else conditional statement. So I'll insert one of those from the control structure submenu. We'll do an if-then-else. And notice here that when I insert an if-then-else, it gives me kind of two different cases where I can insert code. So I'd start by saying, like, what was our condition? So we could maybe start by saying, hey, if our guess, which our guess is actually represented by the variable I in this case, I think. So if I is equal to target, so if whatever we guess for I is actually the right number, then let's display something like correct, oops, and like a little celebration. Else, which means that our guess, I, was not right, was not equal to target, then maybe in that case we would display something like guess again. I think that sounds, maybe that'll work. Thoughts on that?
Okay. Do you think we can put like a wait statement in there somewhere so that we can see the feedback on the screen as we go through it?
Gotcha. So like when we ran this program just a second ago, it went really fast. So maybe if we add in like a wait for a quarter of a second or something, then that would let us see the values or see the feedback for each guess kind of as we went. So maybe something like that. Okay, I like it. So let's run our program to see if it automates the linear search guessing structure that we've been thinking about. So I'm going to go ahead and Control R to run this program. Do lin search, how many numbers? We'll still say 20, and let's watch and see what happens this time. I'm going to run it one more time, watch again, and the question is, what do you notice when we run this search? Do you have any like feedback on how it works or how it doesn't work? Any ideas on why the program is running the way that it is? So I'm going to run it one more time for 20 numbers. So take a minute and share your noticings and some of your thinking in the chat. Is our program working as we'd like it to? Is there anything we need to fix here? What are your thoughts? And I'll just kind of scroll back up so you can see the output for the program again.
So Michelle, somebody's saying that our search is going through all the numbers in that for loop, even when the target number is actually matched. Or right. Someone else said the correct answer was, yeah, the correct answer was guessed, but it just keeps, it still continues through all of them.
Right. So then we might wonder, like, how might we fix this issue, right? In this case, it guessed the correct number after 7 guesses. It should have, like, stopped there instead of kept guessing. So any thoughts in terms of how we might fix that within the code, right, and to keep it from guessing through all the way or whatnot? And this is actually a command we haven't looked at before, Tony, I don't think, in any of our previous webinars. But think about like what you were saying about how like it kept going even after it found the correct answer. After it found the correct answer, it should have just quit. It should have like exited out of the program. And so one of the commands that we haven't used before, but we can use here now, is actually an exit command. And we could put it here inside the if statement that if the guess is equal to the target, then display correct, and then exit out of this loop. So we could do a menu, I think, and go down to option number 5 for transfers and insert an exit command, I think. I kind of have my fingers crossed here. And then let's run this program a few times to see if it operates as we designed it to. We just made one slight change here. So I'm going to go ahead and Control R to run the program. Lin search, we'll still do 20 numbers. Oh, guess again, guess again, guess again, guess again. It's guessing through sequentially, though, like we wanted it to. It's acting like a linear search. Uh-oh, we're getting up high. Oh, my gosh, y'all, it was the 20th one. That was like the most inefficient case, right, of this particular search. Let's try one more time. How many numbers? 20? Ooh, correct after 5 guesses, and notice that this time it kicked it out and quit out of that loop and kind of shut it down instead of continuing through the other 15 guesses. Awesome. I think it kind of operates the way that we want it to. So any other thoughts or questions on linear search? Feel free to kind of add those into the chat. Tony, anything else on this one, or do you want to move on to our next kind of search?
Yeah, I'm ready to move on because I agree with them. I think this worked really well, but I'm thinking, you know, what happens if we have a large, you know, numbers, like not 20? What if we do like 100 or 300 or 400? It's still going to take even the calculator a while to go through a linear search.
Yes, so you're like, yes, Michelle, your method was effective, but not very efficient all the time. So let's look maybe at another way. So we mentioned earlier that there actually are a number of different guessing strategies we could use to play this num game program that we started with earlier in the webinar. So Tony actually has another approach to walk us through. So I'm going to start the game num game, and we're still going to do 20 numbers for now. There's our 2 high and our 2 low sounds. And Tony's not going to start by guessing 1. So Tony, take it from here. How would you like to figure out the number?
So since we're looking at 20 numbers, I'm going to guess 10. I'm going to jump right into the middle.
Okay, so number 10. Too low.
Too low. So somewhere between 10 and 20. How about 15?
15, okay. Still too low.
Still too low. So 15 to 20. How about 17?
Too high.
How about 16?
Nice. So you won the game in 4 guesses. Okay, so that's a very different approach than the linear search method we looked at earlier, right? So let's consider what Tony's method might look like if instead of running this game with 20 numbers, say we ran this game with 500 numbers, and Tony had to figure out the mysterious random integer from 1 to 500. So I'd like to take a minute and consider and just make kind of a wild guess. How many guesses do you think Tony would need to guess the right number from 1 to 500? Take a minute and share some of your thinking in the chat. And y'all, this is like a random generator. We don't know what the number is going to be. So it might take Tony a while. What do you think? How many guesses do you think Tony would need with the strategy she just modeled for figuring out the random integer from 1 to 500?
That's a great question, Michelle. I'm seeing 6, 9.
Okay, Tina and John are very confident in your guessing abilities. Tony, they think you can get 6. Nobody said 1, so nobody thinks you're going to get it on the first guess. But it looks like, what would you say, we're seeing numbers from 6 to 12 maybe for how many guesses it would take you?
Yes.
So before we run this program, let's first consider if we used my strategy from earlier, 1, 2, 3, 4, right? How many guesses might I need with my strategy? I legitimately might need up to 500, right? Like I don't think people would be saying, Michelle, you're going to get this in 6 guesses. And so let's see how many guesses Tony actually needs with her approach. So Tony, I'm going to run the program, 500 numbers.
Okay. I may need some help in the chat.
Oh, yeah, that's right. Well, we've got everyone in the chat, too, to help us out in case we lose track of where we're at. So what do you want your first guess to be?
I'm going to guess 250.
250, right in the middle, okay? Too low.
Too low. So what would my next guess be? I'm going to try to find the middle. So I'm going to guess 375.
Okay, so you're doing like the middle from 250 to 500, is that what you mean? Okay, 375. Too low.
Too low. So now I need to look at from 375 to 500. So how about, I don't know, what's the middle of 375 to 500?
Maybe like 440. I'm making this up, but maybe somewhere in there.
Sounds good.
Okay, let's try it. 440. Too low.
Okay. So now, how about 470, 475, 470?
470, okay. Too low.
Okay. So 485?
Too high.
Too high. So somewhere between 470 and 485 is 477.
Too high.
Too high. So 473.
Too low.
So 475.
Too low.
So 476.
Okay. You win in 9 guesses. And y'all, that might have felt slow, like as we're trying to think of, wait, like, okay, what am I between now and what's the halfway point, et cetera. But think of like, I mean, we'd be here till 9 or 10 o'clock on Central Time on this webinar if I was still guessing 2, 3, 4, 5, all the way up to 476, right? Like Tony's method was still way more efficient in 9 guesses with this binary search method than the linear search method of guessing each number sequentially. So, and literally, y'all, this result surprises me every time. Like, with 500 numbers, I'm always like, oh, I know it's supposed to be low, but I feel like it's got to be at least 15, right? Like, I can't ever, like, kind of wrap my mind around how few guesses it takes with this kind of method. And this searching method that Tony was using is called a binary search. And it's incredibly efficient with large data sets because it allows you to cut the problem in half and then in half and then in half and in half again and again to make it into a simpler kind of setup. So y'all were like right on the money about the number of guesses it would take Tony with that method. Tony, what do you want to do next?
Well, so I get how to do this when you're letting me guess numbers, but I'm wondering, how are we going to do this? How are we going to write code to do this?
Ooh, I like that, because it's a relatively intuitive way for humans to kind of guess through a program, right? Sometimes it takes us a while to think about, ooh, what would be halfway between those two numbers, but we kind of know what we're doing, but how would we write a program that automates this guessing is kind of like what it sounds like you're saying. So let's actually start by formalizing this binary search method for a set of 20 numbers. And so for this, we're going to move back to the slides, and we're going to consider this set of 20 numbers, the numbers 1 through 20, kind of like the first number set that Tony was guessing with. And I'd like us to think about, like, how did Tony determine the first number to guess? And we're going to kind of think about this theoretically and then apply that to write the code. So Tony kind of thought about, okay, well, if my lowest number is 1 and my highest number is 20, then I need to guess the number that's kind of halfway between those two, right? So somewhere around 10 would be a pretty good first guess. So maybe something like that. Is that how you kind of thought about it, Tony?
Yes, exactly.
Okay. And so mathematically, we're actually kind of finding the midpoint, if you will, between the lowest value and the highest value. So one way to think about this is to take your lowest value, 1, and your highest value, 20 in this case, sum them together, and then divide that sum by 2. And this is actually the formula for finding the middle value, if you will, between two numbers. Except we have a problem here, y'all. If we use this formula, we're going to end up with a problem. Does anyone see it? Like, is there anything problematic about what this formula as written will compute. Does anyone have any thoughts on that? So take a minute and share any thoughts you might have on that in the chat. Yeah, and Jean shares that like we might end up with a decimal value. So like if we computed this, like 1 plus 20 divided by 2 doesn't give us 10, right? Like 1 plus 20 is 21, divided by 2 gives us 10 and a half. But Tony, like if you had guessed 10 and a half as your first guess, that would be like a terrible guess, right? Because there's no chance it could be 10 and a half. Like there's a chance it could have been 10, right? But 10 and a half isn't one of the numbers it could be. So yeah, Sarah adds that like we need our answer to be an integer so that there's at least a chance that that's actually the number. And so one of the functions we can kind of wrap around this is an integer function, or we can think about this as integer division. And basically what it does is it takes the result of that computation and disregards the decimal part of the answer. So in our case, when we divided 1 plus 20, 21 divided by 2, we got 10 and a half. It would disregard that 0.5 at the end, and we would just be left with a value of 10. So it kind of rounds it down to the lowest, to the integer that's the greatest integer under that value, if you will. So at least this way, we'd be guessing 10, which is one possible right answer, instead of 10 and a half, which just can't be the right answer. So let's pause here and code out what we've done so far for this guessing program. And for this case, we actually went ahead and built some of this code in already just to kind of get us started. And so we're going to, like, we think that this code as written kind of matches with our thinking so far. So what we'd like you to do is take a minute or so and kind of read through this code for understanding and share in the chat like what some of the different lines do, kind of make sense of what's going on in this program as written. And it's not complete, it's just kind of, we just kind of got started on it. Let me make this a little bit bigger for us to see. You'll notice that inside this while loop, there's some code missing. But kind of make sense of the rest of the code, this first part, maybe what this while loop's going to do, and then the last part of the code as well. So take a minute or two and share thoughts in the chat about any particular line, either lines that like, I understand what this line's doing, this line is doing such and such, or lines that you're like, oof, I don't know yet what that line is meant to do. So let's take a couple minutes to share some of our thinking. I know many of y'all are typing, so keep doing that. I love how Tony kind of rephrased the prompt. Just pick a line of code and tell us what it does. Could be one of the first ones, could be down later.
So Michelle, while they're looking at that, can you tell us, kind of just reiterate what those first few lines of code are doing for us?
Yes, and I also noticed one thing right now. Tony, I think Tony's been making great comments throughout the webinar, but she's been making them privately to me in the chat instead of publicly to all participants. Sorry about that. I've really enjoyed reading them, Tony, but you might need to change that setting.
The roller on my mouse keeps jumping back over to that. Thank you for pointing that out, Michelle.
Yeah, no problem. I like just noticed 40 minutes into the webinar, so we have like really got this figured out, you know?
I've been jumping back and forth, but it keeps rolling back to that, so I apologize.
Yeah, Good catch. Oh, and Nikki just found something to fix in my line of code as well. Nikki noticed that I set my highest value to be 20, kind of matching with our slide. But y'all, look up here. I asked them how many numbers, right? So they could have said 20, but maybe not. Good catch. So this highest value should really be n, in case they said, hey, we want to guess from 1 to 50 or something like that. Thank y'all. Marcy, no problem. You're in good company. You and Tony were both privately messaging. It's totally fine. Totally fine.
So, and we do have a suggestion that, you know, at some point we're going to tie this back to the music theory that we did in one of the other ones, because we're going to have to put our tones in and so forth.
Yeah.
If so.
Nice. So, Tony, you'd asked me a minute ago to kind of maybe we could talk through some of these lines. Like the first two we had in the program before, right, where the user determines how many numbers we want to guess from, 1 to something, and then that second line of code is going to find a random or determine a random integer from 1 to that highest value and save it into a variable called target, right? And then Nikki helped us kind of make sense of this lowest and highest. Lowest possible value is 1. Highest possible value is n, not 20, it's n. Thank you, great catch. I guess this next line of code, this is what we were just looking at on that slide, right? That we're going to average the lowest and the highest and then take the greatest integer value of that. And let's store that into guess, okay? And then, Tony, this next line reminds me of something you added in before about, hey, let's display what our guess actually is so that the user can see what's being guessed. So then from there, we have a while loop here, and it looks like this while loop is only going to run if guess is not equal to target. Like, what does that mean in practicality of this program? I guess that means, like, whatever you guessed here, so say you guessed 10 as your first guess, that wasn't right. Is that a good way to think about it? Like that you didn't guess the right answer yet, right?
Yes, that's what I'm saying, that it was a wrong guess. So what's going to happen?
Got it. So we're going to have to do something in here if your first guess is wrong. But, hey, say there's a chance that 10 could be the right answer, right? So if your guess was equal to target, then this, like your first guess, this whole while loop would just be skipped, right? Because it only runs while your guess is not equal to target. So if you guessed it right from the beginning, it's going to skip over that and jump down here to say correct and just celebrate with you, you're done. So now what we need to think about is what should happen within this while loop. And we said that this while loop will run if our first guess is not the actual target value. We didn't guess the right number right away. So let's kind of go back to the slides here for just a second, and let's think about this. So what happens if Tony's first guess, this number 10, is not correct? What would happen? So again, you're going to get some kind of feedback maybe about that your guess was too low or too high, but how would you then explain, like, what happens next or what should happen next? So take a minute or two to share some of your thinking in the chat, and you'll want to make sure you're sending your chat messages to all attendees.
Actually, Michelle, if I could jump in, we actually want their chats sent to all participants. That way everyone sees it, including us, too.
Thanks, Mike. It's like I've never run a webinar before, like seriously. So thank you for fixing us on that.
So Michelle, I'm seeing somebody say we need an if statement in there. Like if guess is less than target, then something should happen. Like we should send a sound, or it should, you know, maybe say something to let us know.
Okay, so let me try to make sense of what they're saying. So say you guessed 10, and that's less than the target. So that means you guessed too low, is that right? Am I thinking about the logic correctly on that? Okay.
Yeah.
So then think about what Tony did. If she guessed 10 and she got some feedback that said, nope, and your guess is too low, what did she think about? Like, what did you say when you did that, Tony, like after you got that feedback?
Yeah, so if my guess is too low, then I'm going to look at that top half of numbers. So now I'm going to have to guess between 10 and 20. And I'm going to change my guess to the middle of there.
So now you're saying, I know my lowest isn't 1 anymore, it's actually 10. I know this number cannot be any lower than 10, right? And then you're going to come up with a new guess that's halfway between lowest and highest, if that's fair to say. And, oops, I'm totally moving the wrong thing. And your new guess will be halfway between this new lowest and highest. So you actually moved your lowest value up when you got feedback that your number was too low. Then I'm seeing someone share in the chat, well, the converse situation is what if instead of getting feedback that your guess was too low, you got feedback that your guess was too high. Then we would take this highest score all the way down to the middle, and we'd say now we have to determine our guess, and it's going to be halfway between this lowest and highest. You probably would have guessed something like 5 in this instance. And so there's actually 2 different situations here, right? Like either we guessed too low and we moved lowest up, or we guessed too high and we moved highest down. And so we're going to kind of pause here and try to code part of this out and think about what that might look like. So let me erase this kind of missing code section. I'm going to insert, I think I'm going to do another, oh, I want to do this the other way, sorry. I'm going to switch back over to this view. I think I'm going to use another if-else because there's still these 2 conditions, right? Either we guess too low or we guess too high. So I'm going to insert a control structure with an if-else because it gives me the space for 2 conditions. And then we might just kind of start with like what you said. Let's say our guess was less than the target. Our guess was too low. We might then display a message of too low. We could also do a sound like someone mentioned, but for now we'll just do a display statement. And then let's think about what we actually did in that instance, right? If our guess was too low, then we actually changed our lowest value. Our lowest value is no longer 1. Our lowest value gets whatever our guess was, right? Our lowest value moved up to 10 or whatever Tony had just guessed because we know it can't be any number lower than that. We could copy and paste these 2 lines of code down into the else situation. The else would represent not if your guess was less than target, but if your guess was greater than target. So in that case, maybe you guessed too high. And then here, we don't need to adjust the lowest, right? Our guess was too high already. So we're going to bring our highest value down to whatever guess was. Maybe something like that. That could maybe kind of represent the ideas that we were sharing in the chat about these 2 situations. So from here, these kind of if-else help us narrow the scope down to the half of the numbers, kind of like we were looking at here. But then we're going to need to copy in 2 more lines of code. We have to do a new guess. We'll still use the same formula of finding the midpoint between the lowest and highest and making it an integer value. And then let's also display what that guess is. So I'm going to copy those lines of code down into this while loop. So we have a new guess, and it'll display what the guess is. And then maybe Tony had kind of encouraged us to think about this earlier. Maybe we'll add in a wait statement of 1/4 of a second so that we can see what happens. So let's see if this works. Let's see if this kind of models a binary search like Tony was kind of narrating for us earlier. So I'll go ahead and Control-R to run this program. How many numbers? Say we start with 20 numbers. Guessed 10 in the middle. That was too high. Then it guessed 5, kind of the middle of the lower half, and that was actually correct. Well, that was kind of lucky. Here's a sequence where it goes 10, 5, 7, 8, and guesses correctly. I wonder what would happen if we run the same program with 500 numbers. So could you see it kind of doing the binary search there? Guess in the middle, too high. In the middle of the bottom half, still too high. Middle, middle, all the way down until it ended up on the correct answer of 4. So any thoughts to share in the chat for this? You can send them to all participants about how this program kind of operates as a binary search, kind of cutting the situations in half again and again and again, looking for that correct answer. So feel free to share any questions or thoughts in the chat. And there's more that we could do with this. Like we could think about how could we add sound, how could we add in a counter that's keeping track of how many guesses it actually took, et cetera. But really our big ideas here were to model the differences between linear search and binary search, and also for us to do some of the thinking about how we would actually code out those searching processes. Tony, anything else to add on this before we move into a quick sort?
The only thing that stands out to me, Michelle, was that I'm afraid that I might have forgotten was how you put those 2 lines of code right there at the end inside of that while loop, because that while loop was going to keep on going, right, unless we asked for that, unless we had it get that guess value again and inside of that loop.
Yeah, that's a great thing to make explicit, that it wasn't enough to just adjust the lower or the lowest or the highest. We also then had to use that new lowest or highest to determine a new guess, right? So that we would have a new guess that was when the while loop circled back up, it would check that new guess against target to see, hey, did we guess the right number yet? Nope. If not, keep guessing. If so, kick out and celebrate that you got the right answer. Yeah, that's a great thing to make explicit. Thank you for that. Okay, so we have about 6 minutes left, so let's jump over and talk about and think about bubble sort for a minute or two. And there's like so many cool sorts we could think about, but this is one we can look at kind of quickly to kind of get an idea for how we could extend these ideas up to sorts. So here's some possible pseudocode for one pass of a bubble sort. And a bubble sort is going to work on an array called, we'll just call the array A in this instance. It's going to use a for loop that starts with an index of 1 and goes almost all the way through the length of A, kind of stops just before the end, and increments by 1. And let's look at what it's checking. It's checking to see, hey, is the element in the first position of the array greater than the element in the second position, I+1, of the array. So I guess it's kind of looking to see, hey, are the first and second elements out of order? Like, if we wanted this array to be in order, we couldn't have the first element and the second element out of order, right? Like, if they're out of order, then let's switch them. So it's just looking to see if consecutive entries that are right beside each other are out of order. And if they are, we're actually going to go ahead and swap those consecutive entries. So this is like a really quick overview of the pseudocode for a bubble sort, but we're going to take a minute and just see if we can actually code some of this out quickly and kind of get an idea for how this might work. So I'm going to insert a new program, and let's just call it Bubble. And within Bubble, we'll need an array. So maybe we'll start by saying, hey, let's create an array made up of random integers. And each integer is going to have a value from 1 through 20, and let's say we'll have 8 of them in their array, in this array. So we're just kind of creating a random array, and then we might also actually display the array for the user to see. So if I go ahead and run this program, we should see that it created an array of random integers from 1 through 20, and there's 8 of them in it. Run it again, a new array with 8 elements, all with values from 1 through 20. But notice, it's not sorted, right? They're just kind of all mixed up. And what we're going to do is code a bubble sort that will kind of begin to sort this array into its order. So we mentioned that the bubble sort compares adjacent pairs of values throughout the array, and it starts by comparing the first and second values in the array, and then the second and third, and then the third and fourth. So we're doing those comparisons again and again, which makes us think that we probably need a loop structure. And in this case, we can use a for loop if we'd like to. So if we use a loop variable of I, again for our for loop, we could think about what do we want the start and end values to be. And as we saw in a previous webinar on arrays, the first index on an array in TI-Nspire actually has a value of 1, which is different from other programming languages. Many other programming languages start with a first index of 0, but Nspire starts with 1. So we might want to go, I don't know, from 1 to the length of the array, which in Nspire is called dimension of array, but we actually want to stop one value before the end, and we'll look at why in just a second. So then what are we actually going to do? We're going to move through each element in the array, and we want to compare an element to its very next element. So I'm going to kind of insert a few things here just for us to get an idea, but again, feel free to kind of share some of your thinking on the chat. Tony just asked a great question about why do we want to stop one value from the end. But we talked about, hey, we want to look at, is array at I, which would be like when I was 1, that would be array at 1, that would be the element in the first position. Hey, is that greater than array at I plus 1? Is that greater than, say, when I is 1, then array at I plus 1 would be array at position 2, right? Is the element in the first position greater than the element in the second position? If so, yuck, that's not in order. Then we need to swap those two elements. So there's lots of different ways that we can swap, but I'm going to quickly do a 3-variable swap. You could also share in the chat kind of why this works. We're going to create a temporary variable called just temp, and it's going to store whatever's in array at position I. Then what's in array at position I is going to get what's in array at position I plus 1. And then position I plus 1 is going to get whatever was stored into temp. And you can take a few minutes and kind of try to decode this and think about what's happening. But for our purposes, we'll just say that this actually swaps what's in these two positions so that those two positions, at least, will be in order, okay? And then I think that's it. Then we could end our if, and we could end our for, and then maybe afterwards we can display the array to see what happens. So it's going to cycle through and compare element 1 to 2. If they're not in order, it's going to switch them. And it's going to look at 2 and 3. If they're not in order, it's going to switch them and go all the way through the loop. So let's go ahead, or through the array. Let's go ahead and Control-R to run this program and see what happens. So what happens here is, remember, this first display is the original array, and then the second one is after one pass of the bubble sort. So it looks like it switched the 19 and the 1, then the 19 and the 3, then the 19 and the 14, but then it left the 19 there. Any thoughts on why? So at that point, it would have had 19 against 20. 19 wasn't bigger, so it didn't switch. Then 20 to 13, 7, 2, etc. So this is just one pass of the bubble sort. There's a program in the files that you'll receive for today that kind of expands this a little bit further and takes the code that we just wrote, which is right here, and nests it inside another loop that instead of just moving once through the array, will move through the array 8 times, or however long the loop is. So now if we run this program, we would see that the array ends up being totally sorted after all the run-throughs of the bubble sort. So that was a really quick overview of bubble sorts, but what we want y'all to think about here is that all of these searches and sorts that we learn about in pseudocode or in other languages, we can actually code out on the Nspire to test our coding abilities and also to think more deeply about these ideas. So Mike, I'm going to pass it back over to you. While I'm doing that, please feel free to continue the conversation in the chat, everyone, about ideas that you've learned about searches and sorts and kind of these advanced topics in computer science.
Thanks so much, Michelle and Tony. To receive a certificate of attendance for tonight, go ahead and click that link in the chat window. Also listed is a link for the documents that Michelle and Tony used tonight. And in case these links aren't working for you, just look in your email in a couple days, you'll automatically get a follow-up email by attending tonight. And that follow-up email will be 3 links. 1 link will be for the recording, 1 link for the certificate, and 1 link for the documents. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. And as was mentioned earlier, this is the last part of a series that we did this past spring on advanced topics in computer science. And you can feel free at any time to go back to our website and view the on-demand webinars, and you can go back and at your own pace look through any of those 4 webinars in this series. So thanks so much, Michelle and Tony, for everything you prepared, not just tonight, but again for the entire series. It was a lot of fun to walk through this and to learn from you guys. So thanks so much for everything.
Thank you, Mike. Thank you, everyone, for joining us.
That was fun.
And thanks again, everyone, and we hope to see you back online real soon. Have a great night.